All right, we shall get started then. And this week we are working in chapter 4. Okay, so let's just kind of recap what we've done so far. So, on our first day, we talked about why we learn statistics, and it's all about taking data and drawing meaningful conclusions from the data, right? Trying to make conclusions from limited data that we can use to understand our lives and the world around us. And then the second week, we talked about, well, how can we look at data and describe it? And in particular, last week, we looked at how to describe numeric distributions, okay? And so what are some things that you want to talk about? I think there were 3 things, maybe even 4 things that we're supposed to talk about when we're describing a set of numeric data, or how that numeric data is distributed, the distribution of numeric data. Yeah.
The shape, the spread.
Yeah, the shape of the distribution, or the shape of the data. We have the spread of the data. The center, okay? And then maybe the 4th, which we didn't really get into, was anything unusual. But the center, the shape, and the spread, those are the things you want to talk about. What do we use to describe the center of a distribution? The median and the mean, okay? And they both have their strengths or different uses. What do we use to describe the spread? Standard deviation, the IQR, and the range, okay? So those are ways we can describe the spread, and it gives us an idea of where those numbers, the numeric data, how spread out they are, or if if the numbers are very similar to each other, things like that. And then for the shape, we use words like symmetric or skewed, okay? So that talks about whether, the data, the shape of the data. And then the other thing, when we talk about shape, is how many peaks, and so we use words like unimodal, bimodal, multimodal. Okay, great. Okay, so let's, you know what? Some of you have not given me your email address yet, so I'm going to just pass this around. If you see your name on here, that means I don't have your email address. If your name is not on there, that means I do have your email address, so just pass that around. Okay, so let's, today in chapter 4, we are going to look at 2 numeric variables at the same time, okay? And we want to ask something like, is there a relationship, or is there a link between the 2 numeric variables? We're looking at relationships between 2 numeric variables. Okay. Alright, so I'm going to just make up some numbers here, okay? And let's say these were test scores from last quarter, okay? I'm just making some things up. And let's say one numeric variable is the score someone got on the midterm, and the other numeric variable is the score they got on the final exam, okay? And this is for each student, okay? So let's say we had, Adam and Bob and Carl and Doug and Ed. Okay. Apparently only guys in this class. All right. Okay. And then I'm just making up numbers. Okay. So what is the case in this table here? Each student. Okay. So Adam is a case, and Carl is a different case, okay? And so each student, let's say Adam scored an 82 on the midterm, and on the final he got a 78, okay? And let's say Bob got a 95 on the midterm, and on the final he got a 97, okay? And Carl, let's say he got a 65 on the midterm, and on the final he got a 55. And Doug, let's say he got 85 and 78. And Ed, let's say he got 73 and 78. Okay? And we want to know, is there a relationship between someone's midterm score and final exam score? Okay? This might be a little too broad. Okay, so so what we can do, we can look at the midterm variable all by itself, and we can create like a dot plot, yeah? So let's make a dot plot for the midterm score. So again, all dot plots, we got to create an axis first. Let's see. Adam shows up at 82, so a dot right there. Bob is at 95. Carl at 65. Doug at 85. Ed at 73. Okay, so this is a dot plot showing scores on the midterm. Okay, now let's make a dot plot for the final exam. Use the same. So what do we have? We have 78. And 97. And 55. And 78. 78 again. Okay. All right, so from here, so we're looking at two dot plots. Does this show if there's a relationship between midterm score, someone's midterm score, and final exam score?
No.
No. Okay. It tells us the spread of midterm scores, and we see, there's quite a bit of range. But then, for the final exam, we see a large range. Okay, large range between 55 and 97. But then we see 3 people getting the same score. Okay, so that would affect our standard deviation quite a bit, right? Standard deviation kind of measures the overall spread. What would the IQR be? I don't know what it would be, but it would be really small, right? Because it's probably like 0. The IQR, Q1 and Q3 are probably both at 78 or something. Okay, with 5 numbers, it gets a little weird. But right here, we don't really see a relationship between the two numbers. Okay, so the relationship is not visible. We only see kind of the distributions themselves. Okay, so we only see the distribution of each variable. Okay, so if we want to investigate if there's a relationship, we can create something called a scatterplot. Now, it might be tough to see any kind of relationship when there's only 5 people and the test scores of 5 people, but I'm just going to do my best here. So let's say this is I don't know if that's even. Okay, so we'll go. Alright, so this is Alright, so what we're going to do now is we're going to represent each pair of points. So this will be the x-axis, will be the midterm score, and the vertical axis will be the final exam score. So Adam is going to be a point at 82, and the height is 78. So somewhere right around 82 and 78. Okay, that dot represents Adam, showing that he got an 82 on the midterm and a 78 on the final. Bob is going to have a point at 95 on the midterm and 97 on the final exam. So somewhere around here. Now it's a little bit tougher for me to do the graphing on the board, but I hope you guys can see what I'm trying to do. Okay. Carl got a 65 on the midterm and a 55 on the final. He has a dot somewhere around there. Doug got an 85 and got a 78. So he has a dot right there. And Ed got a 73 and a 78. Awesome. This seems like it's over 80. Okay, well all of these should be just a little bit lower. Okay, well anyway. So we have this now on our graph here. Now, does it appear that there's a relationship? It might not be strong, but does there seem to be some kind of relationship between someone's midterm score and final exam score? Yeah, no? Okay, well, what would that relationship be?
They're similar.
Average? Okay, I don't know what we mean by that. Okay, so let's say a newcomer comes, all right? And, okay, so let's say Frank. Frank comes along and he gets sick and he can't take the final exam. And but he says, I'll come in. He has the doctor's note, and so I say, okay, well you can take the exam a little bit later. That's fine. Okay. Let's say Frank got a 92 on the midterm. Can you make a prediction for what Frank might score on the final exam?
Around 70.
At least
80,
92?
80, 90?
80, 90?
Well, wouldn't it be between the lowest and the highest?
Okay, so if Frank scored 92 on the midterm, would you be surprised if he scored a 50 on the final exam?
Yeah.
Yeah, you'd be very surprised, okay? If he scores a 90% on the final, would that be surprising to you?
No.
No. What about a 95%? No. So those seem like reasonable numbers, okay? So I'll just say, oh, Frank scored a 90, okay? And so he would be right here. Okay? And that seems completely reasonable, okay? And let's say Greg comes along, okay? And let's say he scored a 60 on the midterm. What do you think he'll get on the final exam? 65? Okay. So you're thinking something in the 60s, maybe 50s, 70s, okay. But you would be surprised if he scored a 90 on the final, yeah?
Yes.
Okay. You got a 60 on the midterm, you'd be surprised if you got a 90 on the final. And so let's say he got a 60 on the final, okay? That would not be surprising, okay? So we're getting these extra dots. So even though nobody has explicitly said it yet, we have an idea. We've established some kind of relationship between someone's midterm score and final exam score. And what is that relationship?
They're similar.
Okay, we're expecting someone's final exam score to be somewhat similar to their midterm score, okay? Or basically, if we just want to be really general, we say if someone's midterm score is high, we expect their final exam score to be high. If someone's midterm score is low, we expect their final exam score to be low, okay? And that seems to be the overall trend, okay? So we can talk about the trend is that if someone's midterm score is high, we expect their final exam score to be high. And likewise, if they have low midterm scores, we expect low final exam scores. So this is an example of a relationship between two numeric variables. Okay? So when we looked at the numeric variables by themselves, it didn't seem like there was a relationship. But when you look at pairs of points, okay, and it's important that this 82 was linked to the 78 and the 95 is linked to the 97, right? If I just threw these points up, if these were not matched up like so, we would not have this kind of relationship. So here's an example of a relationship between two numeric variables. And what we saw is that if their midterm score was high, we expect their final exam score to be high. If their midterm score was low, we expect their final exam score to be low. Okay. Is it possible for someone who scored a 90, 95 on the midterm, is it possible for that person to then score a 70 on the final exam?
Yeah.
Okay? Yeah, that's possible. But it's not whether it's likely or unlikely. It would just be different from the trend. Okay? So the rest of the trend shows that people who did well on the midterm also do well on the final. But it could just mean that person thought they were doing well, decided to take it easy for the rest of the class, and then come final exam, they did poorly, okay? Is it possible for someone who scored a 60 on the midterm to score a 95 on the final?
Yeah.
Yeah, that's also possible, okay? Maybe somebody's, they realized, uh-oh, I got to work hard, and they worked really hard and studied and did well on the final, okay? That can happen. All that means is just that particular student doesn't fit the rest of the trend, okay? So anytime, and you can imagine, let's say I had 60 students and I decided to plot all 60 students and their midterms and final exam scores, and it never looks this nice and clean, but let's say okay, if we see dots forming kind of this a cloud, and maybe an overall trend if we want to summarize it with a line that kind of goes through the middle of the points, okay? Anything in this shape, so basically this, a trend like this is known as a positive trend, okay, or positive relationship. Okay, so the relationship between midterm scores and final exam scores is positive, okay? And what that means is that when one variable increases, we expect the other variable also to increase, okay? On the other hand, we have numeric variables. You can pick two numeric variables where the dots form this kind of shape. All right. What do you think this one's called? A negative trend. Okay, negative trend or negative relationship. Alright, and that means as one variable increases, we expect the other variable to what? To decrease. Alright, with a positive trend, if one variable decreases, what do we expect the other variable to do? So, positive relationship. So, we said if one variable increases, we expect the other variable to also increase. Okay, if one variable decreases, we expect the other variable to also decrease. Okay, so they change together. They increase together, they decrease together. That's a positive relationship. They go up and down together. Negative trend, when one increases, the other decreases. Okay? If we decrease one, what happens to the other? It increases. Okay? So let's think of things that have positive relationships and negative relationships. Okay? So can you think of two numeric variables that might have a positive relationship or two numeric variables that have a negative relationship? Sure.
study time and better quiz grades?
Okay, study time and quiz grade, okay? So those are two numeric variables. How much time someone spent studying, so did they spend 20 minutes studying, 60 minutes studying, 5 minutes studying, okay? And do we expect a positive or negative relationship with their quiz grade? A positive. We're expecting overall a positive relationship. We're expecting students in general, okay? Of course this isn't always going to hold, but in general students who study more, we're expecting to have higher quiz grades than students who studied very little, okay? So good example of a positive relationship, okay? So this would be study time versus quiz grade. Alright, what about two numeric variables that have a negative relationship? Time spent on Facebook versus their quiz grade? Okay, I guess that could also be maybe. Alright. Yeah.
Like a lot of smoking and heart health? Or
Okay,
lung
so
health,
lung health or heart health, is there a number that quantifies someone's heart health or lung health? Is there a number that? Yeah, so it's a good idea there, but if you don't have a numeric variable for lung health, right? If we can't go to someone and take the scanner and say, you know, like in science fiction movies, they point to some scanner at you and it says lung health 20% remaining or something, you know, or lung health 80%, or you know, they do something like that. That would be awesome. Everything we could look at numeric variable relationships, but right now that technology doesn't exist. So lung health, we can't just put a numeric relationship just yet. But that's a good idea. Okay. So do you have anything in mind? So here's something simple. Maybe altitude, someone's altitude, and the air pressure outside. Okay. So if you are at the top of a mountain, your altitude is high, and if you take out a barometer, because you carry one in your pocket, what would the air pressure rating be? It would be low, okay? You have low air pressure at high altitudes. We know this, right? And then at lower altitudes, you got more air pressure, okay? If not, that's atmospheric science. Your dose today. Okay, so altitude versus air pressure. Okay. That one's hard? It sounds hard? Okay. Alright, here's a silly example, okay? Let's say you owned a clothing store. Okay? We could go outside temperature versus sweaters sold. Okay, number of sweaters sold. Okay, so the temperature outside versus number of sweaters sold. Okay, these are both numeric variables, right? The temperature outside is a numeric variable. 100 degrees or 40 degrees, depending where you are and what season it is. And the number of sweaters sold, that's clearly a numeric variable. How many sweaters you sold. So if the temperature is high, if it's 100 degrees outside, how many sweaters do you think the store is going to sell? Very few, close to zero, okay? But if it's cold outside, if the temperature is low, let's say it's 40 degrees outside, how many sweaters is this store going to sell? A lot, okay? At least in California, if it hits 40 degrees, everybody would freak out. Maybe they won't even sell sweaters. They would sell like giant coats and I don't know, other things. Okay, so those are. It's an example of a relation, two numeric variables with a negative trend. Okay. Does that make sense?
correlational studies?
Okay, we will talk, no, this is all related to correlation, I just haven't listed that yet, okay? Or talked about it yet, but we'll get there, alright? So, okay, sometimes we've got relationships that go like this, okay? This could be the speed of the car and their gas mileage, right? How many miles per gallon you get, okay, MPG. So if you're parked, if you're in the McDonald's drive-thru and you're moving 0 miles per hour or 1 mile per hour, what kind of gas mileage are you getting? Terrible gas mileage, right? You could, if you're just blasting the air conditioner going through the drive-thru, you could waste quite a bit of gas just sitting there, not driving very far, okay? You know, when you're cruising at 50 miles per hour on the highway, okay, you're getting good gas mileage. Your car is optimized for something like that. If you're trying to outrun the cops and you're going 100 miles per hour, okay, your gas mileage is terrible. Your car is working really, really, really hard, and it's probably not designed for that speed, and you're getting terrible gas mileage, okay? So you might see something like this. This we can't summarize with a simple positive or negative relationship, okay? So anything that has kind of this curved shape, or anything that's not a straight line, okay? So any relationship that cannot be summarized with a straight line we say has a non-linear relationship. Okay? Non-linear. Linear meaning line. Okay, you can see the word line in linear. So it's not a straight line, non-linear relationship. Most often you hear non-linear for storytelling of Quentin Tarantino movies or something like that. Okay? But in statistics, nonlinear means not a straight line. In our class, we're only going to learn about linear relationships. Okay? So these, they can be summarized with a straight line. Kind of draw a line through not all the points, but kind of through the overall trend. And so things with straight lines, those are straight line relationships, those are linear relationships, okay? Linear trends, okay, straight line relationships. Okay, and then let's say we decided to compare someone's shoe size versus their test score, okay? So we said, you know, what was your shoe size? Oh, you wear a size 7. What did you get on your test? You got a 90, you go right there. What size shoe do you wear? You wear a size 10, and you got a 70 or whatever. If we graph this, what would we see? We would see just kind of this big blob of points, right? There's no reason to expect people with larger feet to have higher test scores or lower test scores than people with smaller feet, okay? So shoe size versus test score, we would see just kind of a blob of points. And that would indicate no relationship. So everything we've talked about here, this is a relationship between two numeric variables. And what we've talked about so far is identifying the direction or the trend of that relationship. Okay, so when we're describing a relationship between two numeric variables, let me just erase this. So just like when we're describing a distribution for one numeric variable, there's things we want to talk about. When describing a relationship we want to talk about the direction, okay, which is either going to be positive or negative. Positive or negative, or possibly even no relationship. Okay. We want to talk about the form, which is either going to be a linear relationship or a nonlinear relationship. And technically, nonlinear, there's a whole bunch of subcategories. You can have all sorts of different forms, but in this class, we're only going to concern ourselves with linear relationships, either straight line relationships or relationships that aren't straight lines. And the last thing is the strength of the relationship. Okay? And the same words you would use to describe how strong someone is kind of are similar to the words that you use to describe a relationship. So you can say weak or strong, weak to strong, moderate, things like that. So something in between would be moderate, very strong, very weak, things like that. The strength of the relationship. All right, what does so we've already talked about the direction and the form, okay? Again, just a quick recap. What does it mean to have a positive relationship? Yeah, so when one increases, the other increases, and when it decreases, the other also decreases, okay? And negative, they go in opposite directions, okay? When one increases, we expect the other to decrease. Alright, so when we're talking about strength, this is kind of a measure of maybe when you create a scatter plot, you can measure the strength just by seeing how much scatter there is, okay? So a strong relationship will have very little scatter. And it means we could predict one variable based off of the other variable very well. Okay, we can make very good predictions based. one variable based on the other. Okay, so something like this would be how many pounds of meat you bought at the grocery store, or how many pounds of ground beef you bought, and how much you paid for your meat, okay? We would expect a very strong relationship, okay? If you buy 1 pound, you'd have to pay this much. If you buy 2 pounds, you'd have to pay this much. If you bought 2.5 pounds, you'd have to pay that much. And so basically, if we know how much meat you bought, we can, and we know basically the price per pound, we can predict very well how much you had to pay for all of that meat at the grocery store, right? Okay, so this would be a very strong relationship. So pounds of meat purchased, price paid for meat. Okay, so that's a very strong relationship. Okay, on the other hand, a weak relationship will have quite a bit of scatter. In the scatter plot. And that means our predictions for one variable based on the other will not be super great, okay? Our predictions will not be very good. It'll be better than not knowing anything, but maybe it won't tell us too much. So I'm trying to think something that might have a weak relationship. Maybe someone's would have a weak relationship. Okay, maybe someone's income versus their IQ. Okay, so all right. So in general, people with higher IQs tend to make more than people with lower IQs. That's true, but people with high IQs, can make a wide range of income, right? So you can have some very smart people who are very rich, some very smart people who don't make a whole lot of money, okay? And then on the other hand, you can have people with lower IQs that that make very little money, and you can have people with low IQs that make a decent amount of money, okay? So so you might see, so overall there might be a positive trend, okay? But we would see still quite a bit of range, or quite a bit of scatter between someone's IQ and their income, okay? And, you know, the IQ is supposed to measure how intelligent someone is, but it only measures based on what the IQ people say it measures intelligence, right? And so, you know, maybe there are people who, quote, have a lot of street smarts and can, have managed to make quite a bit of money, but then, you know, when they take an IQ test, it says your IQ is not super high or whatever, and then I'm sure we could think of celebrities who make quite a bit of money, but maybe they aren't known for their brilliance. So we would see quite a bit of scatter, and so knowing someone's income, if I said, oh, so-and-so makes this much money, how well can you predict their IQ? Maybe you can't do a very good job, okay? Maybe if I tell you someone makes, you know, a lot more than average, you might think, oh, well, maybe their IQ is a little bit higher than average, but you could be wrong, okay? And so on and so forth, okay? So those, that would be something with a weaker relationship. So we have, when we were talking about the spread of a numeric distribution, we said there were numbers that you could use to describe the spread. And we had numbers like the range, and the standard deviation, and the IQR. Okay? When we're talking about a relationship between two numeric variables, okay, we have a number that will tell us about the strength and the direction, okay? And that number, this is a numeric summary. Summary for a relationship between two numeric variables, and this is called the correlation. Correlation. Sometimes we call it the correlation coefficient. Okay. And all this is just a number, a single number that we use to describe the direction and strength of a relationship, okay? Don't lose the big picture here, okay? When you see the correlation coefficient, it's a number and it tells you about the strength and direction of a relationship. Just like when you see the standard deviation for something is 50 pounds, okay? If I tell you the standard deviation for the weight of an animal is 50 pounds, it just tells you about the spread of the different weights, okay? So some animals weigh more than others, and the amount of spread is about 50 pounds, okay? So that's what that means. So numeric summary for a relationship between two numeric variables, we've got the correlation coefficient, okay? And this tells us about the direction and the strength. Okay, so the symbol that we use for correlation is R, like relationship, okay? And R can take on any value between -1 and 1. Okay, so this means R can be any number between -1 and 1. Okay? The sign of R is the direction of the relationship. Okay, so if R is positive, you have a positive relationship. If R is negative, you have a negative relationship. Okay. R is negative. Alright, if R is 0, that means there's no relationship. So R equals 0 means no relationship. And if R is close to 0, the relationship is weak. And if R is far from 0, so what's the furthest R can be from 0? -1 or 1. Okay, so if R is far from 0, or so you've got like 0.9 or 0.99 or things like that, or -0.9, -0.95. If it's far from 0, the relationship is strong. Okay. R only makes sense for linear relationships. Okay, it will exist for any, if you give it 2 numeric variables, it will calculate, and you say, tell me what the value of R is, you can get the value of R. But it only makes sense when the relationship is linear. Using R to describe a relationship So R will not tell you the form of the relationship. It will not tell you if it's linear or nonlinear. How can you tell if a relationship is linear or nonlinear?
It's straight, positive.
Okay, well, how do you see if it's a straight line or not? Okay. What do you have to make?
Scatterplot.
You've got to make a scatter plot. Okay, you've got to make a scatter plot first to see the shape of the relationship, the form, whether it's linear or nonlinear, and then you can decide whether or not it makes sense to use R. Okay? Because you can get R, and maybe it'll say R equals 0.2, but that doesn't tell you if the relationship is linear or nonlinear. Okay? So, always make a scatter plot. To see the form of the relationship. Okay. Alright, so if you see a scatter plot, something like this. What might the value of R be?
-1.
Yeah, R here would be equal to -1, okay? Alright, so I'll just put some plots up, and I'll ask you what is R. Don't shout it out. And then we'll I'll let everybody think about it for a second, because I know some of you guys are a lot quicker than others, and that's okay. But we'll just give everybody a moment to just come up with some number in your head, okay? So let's say what might the value of R be for this scatter plot? Okay, so just think of some number in your head, what you think R might be equal to. And R might be equal to 0, or something close to 0, okay? Maybe 0.02 or something, okay? 0 or close to 0. Does that make sense? No relationship between these two things, okay? Okay, think of a number for R. All right, what do you think?
0.98.
Okay, so R is going to be positive, and I'd say this is a pretty strong relationship. Okay, I mean, there's a bit of scatter, but if I gave you some number, you can probably make a decent prediction about the other. So R might be like 0.9. Okay, I'm just making up a number. A little bit of scatter, but pretty strong relationship, and it's positive. Okay. What might R be here? Think of a number. Okay. What do you guys think?
0.
Like negative.
Yeah, okay, so R is negative, so a lot of you guys can kind of see the negative trend, but there's a lot more spread. So maybe negative 0.4 or 0.5 or something, okay? So it's a lot weaker. I don't know, okay? And depending on things like this, so just kind of get a feel for the different values of R, and you can look at page 140 for more examples. Okay, why don't we take a short break right there, and we'll come back in about 10 minutes and finish up.